How are you guys? Been better, huh? Sorry to hear that. So, last time, we spent some time in class and we basically just worked on our assignments, right? We hopefully remember that Wednesday this week we're going to have our Chapter 2 test. We're going to start class today. I'm going to run through a test description, and then we'll take some homework questions from you guys, and then kind of see where we're at from there. Okay? So this test description is in the content library. You can write this down if you want, but there's really no need because you have access to it as long as your OneNote's up and running. Okay, so you'll have two questions where we have to convert from degrees to radians. You should be able to do that.
Thank you.
You're welcome. Sorry. No problem. You should be able to do that while leaving your answer in terms of pi as a fraction. Well, I should say a reduced fraction. You should be able to go from radians to degrees. You have two questions like that. You'll have two arc length questions. Shoot, do I need to put the formula in there? No, let me look real quick. It's an important question, right? Okay, so you'll have two questions about arc lengths. You'll be given both versions of the arc length formula. You'll have to know which version to use, depending on whether you're dealing with radians or degrees, but I'll give you both versions. You should be able to use a right triangle to write the 6 trig ratios, so Sohcahtoa basically. There'll be two questions like that. You should be able, or there'll be two questions where I give you one of the trig ratios and ask you to find the other 5. There'll be one question where I give you a point on the terminal side of an angle and ask you to find the 6 trig ratios. There'll be one question where I give you one of the trig ratios and the sign of another ratio and ask you to find some other specific ratio. And then two questions where I ask you to evaluate a trig function using the unit circle. Again, all this stuff is in the content library, so if you ever want to go and look back at this again or don't feel like writing it down right now, it's no big deal. It's all there for you. Clarification question about anything that we've just kind of talked about here. Hopefully this helps focus the studying a little bit. Ariana?
So there's going to be no questions that are like, don't use your calculator.
Here's what I would say. I mean, there's questions where you're allowed to use your calculator the entire time, for sure. There's questions, though, that like, if you did like cosine of 210 on your calculator, and I ask you to use the unit circle, the decimal from your calculator is not going to be what I'm looking for. I'm going to be looking for the exact answer from the unit circle. But it's not like I'm going to take your calculator away. Kind of, does that make sense? So like you have your calculator the whole time, but some of the stuff, the answers that we're looking for, like in a form that your calculator wouldn't be able to give you, right? It can't give you root 2 over 2 as an answer. It's going to give you like 0.707. It's like, well, you know what I mean? Okay, Joe.
So for the problems that deal with finding the secant, theta, and like all those kind of things, like there's 6 of them, I think.
Yeah.
So we need to memorize the what's the word? I don't want to say formula, but like the ratios.
Yeah. Okay. So so let's talk about the stuff that you'd want to have memorized, because that's an important question, right?
Yeah.
So you definitely want to know the conversion factor going from radians to degrees or degrees to radians, right?
Yep.
You should know the 6 trig ratios, so sine, cosine, tangent, cosecant, secant, and cotangent. You should know that sine and cosecant are reciprocals. Cosine and secant are reciprocals. And tangent and cotangent are reciprocals.
Say that one more time, sorry.
That's okay. Let's just write it down. So sine and cosecant are reciprocals. Cosine and secant are reciprocals. And then tangent and cotangent are reciprocals. And the way that I remember that when I was a student is I just remembered that like no cos go together. So like when I'm finding the reciprocal pairs, I know cosine doesn't go with cosecant or cotangent, it goes with secant. And that's, once I have that, tangent and cotangent, easy to remember those go together. So it's just telling apart whether like should cosine go with cosecant or secant. And if I know that the cos don't go together, then it's fairly easy from there. Is that okay? So again, like these guys are the reciprocal pairs. So you should know the right triangle definition for these things. So basically like Sohcahtoa, right? Do we remember how to spell the acronym there?
Yeah, opposite hypotenuse.
So it says sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And this really also tells us, if we remember the reciprocal pairs, it tells us cosecant, secant, and cotangent also, right? If sine and cosecant are reciprocals, then cosecant should be hypotenuse over opposite, right? So if I remember the reciprocal pairs, I know Sohcahtoa, then I also know how to find the right triangles for cosecant, or secant, and
Yeah, I've
cotangent.
been like doing that, but I've never put together they're just reciprocal with each other.
Yeah.
I don't know why I just didn't click.
Yeah. So again, just trying to simplify things down, right? You should know also the standard form definitions and kind of when to use that. So these guys are used when we're talking about like a point on the terminal side of a standard position angle.
That's when we draw that triangle, right?
Yeah, where you have the XY axis and you draw your angle, then you make your reference triangle. Yeah, that's basically what we're talking about. And now these definitions are really the same as Sohcahtoa, right? Just Y is the same thing as opposite, X is the same thing as adjacent, and R is the same thing as hypotenuse. So there, if you know Sohcahtoa and you know the reciprocals and you just remember those 3 things, it's basically you have all those definitions also. Yes, sir.
So to find R, are we just doing the Pythagorean theorem because that's hypotenuse?
Yeah, so R is definitely
Okay, right.
so R squared is equal to X squared plus Y squared. Sure, that's always got to be true by the Pythagorean theorem. Absolutely. Leo?
Can you draw like a triangle with like opposite, adjacent, and hypotenuse on it?
Sure. So if I draw a right triangle, without deciding on an angle that we're using, without deciding on my theta, there is no opposite, adjacent, hypotenuse. So we have to pick an angle to be theta. For the sake of argument, let's just say that one's our theta. So the hypotenuse is easy. That's the longest side. That's always going to be the longest side. The adjacent then is the other side that makes up the arm of the angle. So that side is the adjacent. And then the side that's across from the angle is the opposite. But if we were talking about, this thing as our angle, that side would now be opposite. This side would then be adjacent. This would still be hypotenuse. So it depends on which angle you're talking about, right? Opposite and adjacent are going to switch depending on the angle. Does that feel okay?
Yeah.
Okay. And then the last one, or the last set of definitions here, is the unit circle definitions. So sine is just the y-coordinate. Cosine is the x-coordinate. Tangent is still y over x. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. And cotangent is the reciprocal of tangent. But this is really still the same thing as the standard position definitions, just with r equal to 1. And how do I know the radius is equal to 1 on the unit circle? Literally, it's the name, right? Unit circle, unit being 1 radius. The radius has measure 1 in the unit circle. That's like what a unit circle is. So it's really the same definition, just r is 1. That's all. So it looks like there's a lot of stuff to remember, but it's really kind of the same thing, just with a little bit of modification, right? It's still basically just Sohcahtoa. We're just changing the names for some stuff. Basically all we're doing. So if you remember kind of like what's changing, you don't have to memorize like 6 new things. It's like, okay, same as Sohcahtoa except for this. And then this one is the same as that one except for this. And that, I think, makes life a little bit easier to memorize. I was always a bad memorizer. It's not my strength as a student. I was a very good understander or an applier, but I was not a good memorizer. So I was always looking for like, how can I understand this so I don't have to memorize it? So it just like seems obvious and makes sense. Or so I can memorize one set of things and just like make the appropriate modification each time, which is the other way I'd like to go about doing it. If I have to memorize something, like memorize it in a general way so that I can get most bang for my memorizing buck, so to speak. Okay. Haley, did you still have something?
Yeah. So we're gonna get a copy of the unit circle, like we don't have to memorize all that? Or...
You will never be asked to memorize the
Okay.
unit circle in this course. I think from this chapter test on through the entire rest of this semester, and maybe parts even of second semester, there'll be a unit circle attached to every single test you take.
Okay.
So just to be clear, that is never going to be an expectation in this course to memorize the unit circle.
There's courses where you have to memorize them?
I think depending on who's teaching what course,
Really? Jeez.
but I'm never going to ask you to memorize it.
Can you label that like that's for the unit circle? Also just like the one with the
Sure. So this is the unit circle. This is for standard position angle. This is for right triangle. Is that good?
Yeah.
No problem. And again, everything that I'm writing down obviously is going to be in OneNote. So if you like me to write it some other way or add some little note to it or whatever, I'm happy to do those sorts of things. Riley, of course. Okay. Do you guys feel okay about test-related stuffs now? We have an idea of kind of the questions that are going to be on it. We talked about the stuff that you'd want to have kind of memorized or committed to memory, and we talked about some of the ways to remember those things to try to make your memorizing a little bit, so it's not a big part of getting ready for the test. It's just like a little part. Do you want to move on to specific questions? Happy to do some of those. So Yeah, Rami?
Start small, so I've got a few more questions.
Sure.
Go over the co-terminals, but in radians.
Sure. Yeah. So do you want to, is there a specific one you want to look at, or can just like any old, I can just make something up?
You just make something up.
Cool. Let's do it. So let's say we have like 19 pi over 6. And I just want to find some angle coterminal to that. So remember the idea for coterminal. So if we have like a standard position angle, I'm just drawing something here, that an angle like this would be coterminal because their terminal sides lie in the same position, right? So if I think about what I did here, the difference between the blue angle and the red angle is the blue just has an extra full rotation before it does whatever the red angle was. Does that make sense? So a full rotation in degrees is 360 degrees. A full rotation in radians is 2 pi radians. And you could just do the unit or the degrees to radians conversion to remember that. You don't have to remember it separately. You could just be like 360 and then convert it. So all I need to do here is I'm just going to be adding or subtracting 2 pi from 19 pi over 6. So it doesn't matter. Both of them are okay. And we can add or subtract 2 pi as many times as we want. All of them are still going to be coterminal. So if all I want is just one coterminal angle, I'm just going to add 2 pi here. To add fractions, I need to make a common denominator. So I'm going to think of 2 pi as 2 pi over 1. And I'll make a common denominator. Should be obvious here that the common denominator would be 6. So I'll multiply the top and bottom of this by 6. So what I have is 19 pi over 6 plus 12 pi over 6, which is going to give me 31 pi over 6. And that's it. Now, alternatively, you could use your calculator to do this. If you're like fraction anxious, it's not too difficult to ask your calculator to do this. So the way that I'm going to do this is I'm just going to leave off the pi's. Your calculator will not be able to handle this question if you leave the pi's on there. But if we just do this as 19 over 6 plus 2, and then press enter, and then we'll go math, fraction. It'll give it to us as a fraction, and we just tack the pi on at the end. So 19 over 6 plus 2 is 31 over 6, and I just add the pi back on at the end. So you can use your calculator to kind of handle that part if you don't like doing the arithmetic by hand, which I don't blame you if you don't. Leo.
Can you just explain to me why we added 2 pi and then subtracted one more time?
Subtracting would have been fine. That also would be correct.
So it doesn't matter what you do on any one of these problems, we add and subtract.
If all you're looking for is a coterminal angle, no, it doesn't matter. If you're looking to like find something that's coterminal that meets some other criteria, then yes, it might matter whether you added or subtracted. So if I had like cosine of 19 pi over 6 and I wanted to evaluate that using the unit circle, then I would want to make sure that I'm adding or subtracting till I got down to a value that's on the unit circle. So unless there's like a reason why you might want to add or subtract, no, it doesn't matter. If all we're talking about is finding something coterminal, doesn't matter. Okay with that?
Yeah.
Jeremy.
So why did you choose 2 pi again?
So if we looked at my picture that I drew, I had this blue angle and red angle that are coterminal because their terminal sides are at the same position, right? The difference between the blue angle and the red angle, the blue I did this full spin, and then I did whatever the red was, right? So a full spin is 360 degrees, which in radians is 2 pi.
Oh,
So it's just the radian equivalent of a full rotation. And again, you could remember that you could remember 2 pi is the same as 360, or you could just be like, yo, I know it's 360, and I'll just convert it to radians like a conversion problem, and that's fine. Joe.
So whenever we're given like a number in pi, that's when we add 2 pi, but if the number's in degrees, we add 360 or subtract 360, right?
Yes.
So if it's asking for more than one coterminal angle,
Uh-huh.
so you did addition, right? If we want to find another one, can we do subtraction and then call it a day?
Well, you could subtract 2 pi from 19 over 6, or you could just add.
Another 2 pi?
You could add another 2 pi.
Another 2 pi, okay.
And you could keep adding. You don't have to do one adding and one subtracting.
Okay.
You can go add as long as you want.
Okay, so we can do that process to find more than one coterminal angle.
Sure.
Beautiful.
Yep. Okay. We feel okay about finding these coterminals. A little bit better. The calculator's nice, right?
Yeah.
Just remember to leave the pi's off and then put the pi back on. And the calculator can handle most of the terrible fraction arithmetic for you. Who's next? Rochelle.
So I'm like struggling with like the 45, 50 degrees, like the 30.
Oh, the special right triangles?
Yeah, I do.
Okay. So to run through those definitions again, we'll start just by doing that. So there's the 45, 45, 90. So the side lengths there, I'm going to use like A's instead of like X's as my variable, because sometimes this involves, like we end up putting this on the XY axis, and I don't like having X's there when I also have X's for X coordinates. So I'm just going to call these A's. So those are the ratios for a 45, 45, 90 triangle. The legs are both the same. And then the hypotenuse is by a factor of a square root 2. For a 30, 60, 90, so the side opposite the 30 is A. The side opposite the 60 is A root 3. And the hypotenuse is 2A. And the place where, at least in the homework, where this kind of came up would be like 51 through 54 there? Or are there ones in the review also? Okay. Should we grab one of those then? So like, let's see. None of these need to be done with 30, 60, 90, or 45, 45. Yeah.
It's like, I don't know if it's the same thing, but it can go up.
Yeah.
Like those ones, yeah.
These ones?
Like the ones, it's like the
Oh, these ones.
Yeah.
Sure. Okay. No problem. Oops. That's not what I wanted to do. Yeah. So I guess, yes, you could use 30, 60, 90 triangles to do these ones. Absolutely. So let's do that. Okay. So 45, 45, 90 triangle. A. So we remember that the A's are the legs and A root 2 is the hypotenuse, right? In this case, I know A is 4. So this side is also 4. And this side would be like 4 root 2. Okay. So if I go to the next one, this is a 30, 60, 90. So the side opposite the 30 is the A. The side opposite the 60 is the A root 3. And the hypotenuse is the 2A. So here, what I have is a root 3 is equal to 12. So I'll go ahead and divide both sides by root 3. Okay with that? And we don't like to leave an answer with a radical in the denominator. So we'll rationalize the denominator by multiplying the top and bottom by root 3. Okay with that? And then I notice 12 divided by 3 can reduce. So that's 4 root 3. So this side is 4 root 3, because that's what a is. And this side then would be 2 times 4 root 3, which would be 8 root 3. Does that feel okay there?
Yeah.
Okay. We're
Yeah.
good? Okay. Rami?
How does multiplying the bottom by root 3 also leave you, or still leave you with 3 in the denominator and not 1?
Sure. So root 3 times root 3 is root 3 times 3. And root 3 times 3 is not root 9. And root 9 is just 3. Does that feel okay?
Yeah.
So it doesn't get rid of the, doesn't just disappear. It just turns into the non-radical version of the number. Okay. Leo, do you have one?
Section 2.1, it's a question 3.
So this is from the review?
Yeah,
What page?
it is the second one.
Page 2?
Yeah, but yeah, those 3 right there.
Sure. Okay. So I'm going to just kind of start with a picture. So it says, find the perimeter of a sector. So a sector is like a slice of pizza. So it's going to look like that. And the parts of our sector are R, that's a theta, and that's an S. Because a sector is just like a slice out of a circle, right? Like a slice of pizza is a cut out of a circle. Same idea here. It says the sector is created by a 3.1 radian angle. So then my theta is 3.1. Intersecting a circle with radius of 18.1. So my radii are 18.1. So far, so good there. It's asking for the perimeter, so that's the distance around. So it's going to be R plus S. So far, so good with that.
Yeah.
Okay. So R is easy. That's 18.1. S is an arc length, right? Since the angle in this case is given in radians, I can use the radian version for the arc length formula. So that's just going to be 18.1 times 3.1. Is that okay?
What's your reasoning behind
Well, I'm looking to find S, right? Because that's that side. And my formula for S is R times theta. That's just the arc length formula. So that's where I'm getting this. So then I just type in the calculator time. Oops. So 92.31. And I guess here, forgot that 0.1 there. And I think these are inches, right? Yeah. Does that feel okay, Leo?
Yeah.
Okay. So similar for the next two, right? Do you want to do one?
Can you do one where it's like degrees and not radians?
Sure. Do you have a preference?
I guess C.
Okay. So it says a 100-degree arc of a circle has a length of 7 centimeters. So this is our picture. Good with that? So it's asking to find R. So I know S is equal to R theta times pi over 180, since it's the degrees version. Okay with that? So I can say 7 is equal to R times 100 times pi over 180. So if I multiply that together into a single fraction, that's 100 pi over 180. Is that okay? Oops, times R. So to get the R by itself, I'm just going to multiply by the reciprocal. Okay with that? And now it's just calculator time. So 7 times 180 divided by, and here I need to use a parenthesis because that pi needs to be in the denominator. If I don't put that parenthesis around there, it's going to divide by 100, get an answer, then multiply it by pi, which is not what I want. So that's my answer. Alternatively, what might be easier is if you use the alpha y equals button to go to the fraction menu and take that n over d shortcut. And then you don't have to worry about the parenthesis. You just type it in how it looks on your paper. And you'll get the same thing. Does that feel okay, Leo?
Yeah.
So 401, I think, right? Centimeters. It's okay. So it's just about, these questions are all just about using the appropriate arc length formula, right? Rochelle?
Okay, it's like super short. I know how to solve it, but I'm confused like what part you're asking for.
Shh.
It asks for the
So we're talking about the review again?
yeah,
Okay, let me go find the section.
like civic math.
So this part,
No, that part.
okay.
So
let's-
I know how to solve it,
Okay,
but I don't know if like it asks for exactly.
yeah, let's talk about that then, right? So are we talking about question 10 or question 11? 10, perfect, okay. So yeah, what you're looking for from here is a fraction, is the answer that we're expecting. Because you could type any of these into your calculator and they'll just spit out a decimal if you're in. So what we're looking for here is a fraction from the unit circle. So let's do A together, say, okay? So first thing I would do is go to my unit circle and see if I see 11 pi over 4, or 11 pi over 3. So if I look around at my radians, I see pi over 6, pi over 4, pi over 3, da-da-da-da-da-da. I don't see 11 pi over 3 on here, right? Which tells me is that, okay, well, if I'm supposed to be using the unit circle, there should be something coterminal to 11 pi over 3 that's on the unit circle. 11 pi over 3 is a little bit over 3, right? 11, or 3 times 3 is 9, and 9 is a little bit a little bit more than, or 11 is a little bit more than 3, so it's a little bit more than 3. Everybody's okay with that? Here we're only going up to 2 pi on the unit circle, so I should be subtracting down. So I need to find something coterminal that's smaller than 11 pi over 3. So I can do this numerically by just taking 11 over 3 and then subtracting 2. That's between 0 and 2 pi, or 0 and 2, really. So I'll take that and turn it into a fraction. So 5 pi over 3 is really what I'm looking for. And I know on the unit circle, sine is just equal to y. So I'm going to go to the unit circle. I'm going to find 5 pi over 3. And I'm going to retrieve the y coordinate. And then I'm just going to write that down. And I'm done. Yeah, so that's where these unit circle definitions that we talked about here at the very beginning are important. So that's how I knew sine was y. It's because I was using these definitions. So if there's a cosine problem, I'm going to take x. If there's a tangent problem, I'm going to take the y and divide it by the x, etc. Does that feel okay?
Yeah.
Good. And again, using the unit circle and being able to find the value on the unit circle is super important moving forward. That's something we're going to use a lot. So you definitely want to know how to use it. Okay? Joe.
Sorry, I zoned out a little bit. Can you explain how you got to 5 over 3?
I agree. Can you just write down what you divided by before that so that it's
Sure.
Thank you.
So all I did, let's do this, you know what? Instead, let's do this visually. So if I take 3 and I divide it by 11, I get 3 remainder 2, right? So I can say 11 divided by 3 is equal to 3 and 2/3. Everybody's okay with that? So if I go back to my picture, I do this visually. Really, I'm talking about 11 pi over 3 is equal to 3 pi plus 2 pi over 3. Okay with that? So I notice that each quadrant is a half a pi, right? That's half a pi, 1 pi, 1.5. This would be back to 2. So I'm just going to count around. So half, 1, 1.5, 2, 2.5, 3, and then 2/3 more. Well, 1/3 is to there, right? 4/3, and then 1 more is to here. And that's the same thing as finding 5/3 numerically. So I'm just counting around. So you could do it that way. Or, if you wanted, what I did was 11 pi over 3, and I subtracted 2 pi, and that gave me 5 pi over 3.
Here, would it matter if you added or subtracted 2 pi?
Well, yes, here it would matter. And the reason it's going to matter is because if I add 2 pi, I'm not going to get a unit circle angle. I'm not going to have a number that's on the unit circle. So all I really wanted to do to check at the beginning to know if I should add or subtract is if I just do 11 pi over 3 and I compare that to 2 pi, it's bigger. So I know I need to subtract. So if the angle is bigger than 2 pi or bigger than 360, you're subtracting. If it's smaller than 2 pi, or if it's smaller than 0, you're adding. That's it. Does that feel okay, Leo? Rami?
In section 2.03, Might have been a mistake, but E is just like an integer, and it says finding things from it.
Okay.
So how do we deal with that? Like, it doesn't have a degree sign. It's fine.
So it's a radian measure. If there's no degree sign after it.
That makes sense. I was just treating the ones with pi and then degree.
Yeah, so if it doesn't have a degree symbol, it's a radian. So you're just going to do plus 2 pi. And you could write, so you could write just literally 2 plus 2 pi, done. And you do 2 minus 2 pi, done. And that would be fine. Or you could type in your calculator and get the decimal. That would be okay as well. You'd have to round that to like 2 decimal places or something, but like.
And can you just go like a little bit above that? You go either one of the ones here to figure out like
These story problem ones?
yeah.
Sure. Okay. Any preference on which one of them we talk about?
And they both confuse me like equally. So
Okay. Okay. Let's just do B because I have a little bit more room to draw a picture here. So it says you're standing on your yard when you notice your friend is on your roof. Your friend measures an angle of depression to you of 26 degrees. You know that your roof is exactly 22 feet tall. How far away from your friend are you? I remember this question. The answer key finds the wrong value on this. So I'm just going to draw a little picture. There's me and there's my friend. Cool. So far, so good. I know this house is 22 feet tall. Now it says an angle of depression of 26 degrees. So when we talk about angles of depression or angles of elevation, it's always talking about from that person's line of sight. So we're talking about the friend that's on the roof. So their line of sight, if they're looking straight ahead, is here, like parallel to the ground. And they're going to be looking down 26 degrees. Cool with that? So the triangle that I'm going to build is this one. I know that this side has to be the same as the height of the house because two vertical things are the same, are parallel and they're the same height. Cool with that? And we're looking for how far are you from your friend. So we're looking for that side. I think in the answer key we've solved for this one, which we don't really want. That would be like how far are you from the house. Anyways, so now I'm just going to use Sohcahtoa. So this is the angle I have relative to this angle. Oops, this side is the opposite, and this side is the hypotenuse. So I'm going to use sine. Cool with that? So sine 26 is equal to opposite over hypotenuse. And I'm going to solve for x. So first thing I'll do is multiply both sides by x to get it out of the denominator. And remember, sine of 22 or sine of 26 is just like a decimal, right? So it's just like, it's just a number, right? So you could use your calculator and convert it into a decimal right here, but I would not do that because when we divide, you're probably going to take your rounded answer. Now you're going to round twice and just, things can get a little bit kooky if you have to do a lot of steps. So it's usually best to kind of just leave it until you're ready to type it in your calculator all at once. So I'm just going to divide both sides by sine 26. And then it's just calculator time. Now, before I do sine of something on my calculator, I do need to check my mode. Since this angle is measured in degrees, I need to make sure my calculator's in degree mode. So I'll press the mode button. I notice that my calculator is in degree mode. If it wasn't, you just use your arrows so that the degree thing is highlighted and press enter so that it highlights, right? So like if I want to put it into radian mode, I just move it down there and press enter, and now it's in radian mode. I don't want to do that. I want to be in degree mode. 22 divided by sine 26. And then just press enter. So about 50.2 feet. Leo?
When you're finding like sine or whatever it's gonna be, how do you know it's opposite or hypotenuse and not hypotenuse or the opposite?
So that's what Sohcahtoa is. So sine is opposite over hypotenuse. Always.
Yeah, so but how do you know it's gonna be opposite or hypotenuse?
Oh, so I'm looking at the 26-degree angle. Relative to the 26-degree angle, this side is the side that's across from it. That's the opposite side. This side is the hypotenuse. It's the longest side. So it just depended on which angle I was using. Is that what you're asking? Or no?
That might just be like making a question up. I don't know. So do you know like the opposite of sine is like CSC?
Okay. That's not opposite. That's reciprocal. Right? So sure, you could use cosecant of x over 22. The problem is, if I go to my calculator, cosecant is not built into my calculator. So that's why I wanted to use sine rather than cosecant, because my calculator, sine, cosine, tangent, all built in. I don't have to do any monkey business to use those. That's what I'm choosing.
Okay, makes sense.
There you go. That's what you're trying to get at.
Yeah.
Yep, good. We talked it out. I figured it out. Yeah, that's a good question though, right? Like, why not use one of the reciprocal ones? And it's just a practical that the calculators haven't built in for me automatically. Joe?
I have a question on 2.04, the unit circle thing.
So that was what we were just looking at, right?
Well, so like for problem C, for example, we have degree. So can we just go over how we do degrees now?
Yeah, sure. So 495, I go to look at my unit circle. It ends at 360, right? So I need a coterminal angle. Should that coterminal angle be bigger than 495 or smaller than 495? Smaller, because I need it to go between 0 and 360, right? 495 is too big. I need something smaller. So I'm just going to subtract 360. So that gives me tan of 135. I go over and I find 135 degrees. Tan is y over x is my unit circle definition. So that's negative root 2 over 2 over, root 2 over 2 over negative root 2 over 2, which is just negative 1.
So because 495 is greater than 360,
You're subtracting.
you subtract it. But for like negative 225,
You'd add.
you add 360.
Exactly.
Get that
Perfect.
number and then figure it out.
Yes.
Okay. And will we always be given like a number? Like 135 was pretty easy to find on the thing, on the unit circle.
You will, if it's a problem like this where I ask you to use the unit circle to do it,
It'll
always come out to be a unit circle value.
Okay. Sounds good.
Yeah.
Beautiful. Thank you.
You're welcome.
Along with here, can we do like one row below it?
Cosine of 120 or negative 120?
No, the question 11.
Oh, sure.
Those are the drawing ones.
Yeah. So here I'm going to use the, excuse me. I have to yawn here. The standard position angle definition. Now you're yawning. So secant is r over x. So that tells me that the r is going to be positive 3 and the x is going to be negative 1. Now, how did I know that the r wasn't going to be the negative 3 and the x couldn't be the positive 1? Right? That's a natural question to ask. Remember, in this standard position definition, the x and y...
Can I see Riley long, please?
Sure, Riley. The x and y are representing coordinates. Coordinates can have positive or negative values, right? The r is representing the distance from that point on the terminal side to the origin. That's a distance, always has to be positive. So the r, always positive. Okay with that? Tangent, I know, is y over x. So since x is negative 1, the only way that y over negative 1 is positive is if y is also negative, right? Everybody happy? So I'll draw my picture. So since x is negative and y is negative, I'm going to be here in quadrant 3. Bye, Riley. Leo, happy with that? Okay. I'm going to build my triangle now. So the x side was negative 1. The y side we don't know yet. And the r side is 3. So I can use the Pythagorean theorem to find the y side. Cool with that. And if you remember, the square root of 8 is the square root of 4 times the square root of 2. Or we could call that 2 root 2. So this is going to be negative 2 root 2. Remember, I know this is negative because I know the y is negative. So my point here is negative 1, negative 2 root 2. Right? That's the x and y point here. Okay, so that was the hard part. Sine theta is y over r. So that's going to be negative 2 root 2 over 3. And I'm done. So once you get the picture, really you're just using the formula and spitting out your answer. Getting the picture in the right quadrant, that's the tricky part. But it's really not that tricky, right? You're just using the definitions to figure out whether the x's and y's have to be positive or negative, and then find the quadrant that matches the signs for the x's and y's. Joe?
So with this problem, we used our, like when it says secant or tan with the theta symbol, we just go find our, like the r over x or the y over x, those values. And then from there, we draw the graph using those for the picture.
Yep.
And it's just the Pythagorean theorem for what we're missing, what we need to find.
Right, because you always know 2 of the 3.
Right.
Okay. So you always use the Pythagorean theorem to find the third one.
Okay.
And you're just using what you know about the 2 ratios to find the correct quadrant.
Okay, sounds good.
Leo?
It's more just a question, like,
Okay.
we have the box, like the grid with the S and R and O.
Sure.
Are we gonna have a question like that, or more of a question like with the triangle? Will we have to plug it into that box on the test?
Sure, it could be formatted like that. Or it could be formatted like, like a story question. But there's no triangle involved. I think you're thinking of the sector,
Yeah.
the pizza slice, which is not quite a triangle because one side is curved. I just want to make sure that I understood what you were saying. Okay. Yeah, it could be formatted either way. Rami.
Go over like 45 and 46 on the homework.
Sure. Problems. Copy.
And all of 47 through 50. I think it's just like general.
Okay. Okay, so we'll do 45. So here's the idea. I'm just going to build a right triangle. To graph that point, I went -2 to the left and went 1 up. So to find r, I can just do the Pythagorean theorem.
I did not draw on that at all. So easy now. I think I got it.
So r squared is 5, so r is √5.
Now it's just the ratio.
And then it's just the ratios, yeah. So like sine theta is y over x, or I'm sorry, y over r. And I rationalize my denominator. It's going to be √5 over 5. Cosine would be x over r. And I rationalize my denominators. I'm not going to show the work that time. And I could just keep going, right? Once you have, you know, it's just about like drawing the picture and then finding the, using the correct definition, right? And then to find the pieces.
And then, yeah, anything from, preferably one angle, one radian example. Those.
Okay. Yeah.
In 2.1, I'm just, the chart will not be on the test, or will it?
2.81.
2.1.
Oh, yeah. So yeah, you could have a problem like that, or you could have like the story problems below it, right? So there is some arc length problems. I'll give you the arc length formulas, but it could be like a fill in the blank for a chart, or it could be like a little story problem. For 47 through 50, so it's saying this is my range of values for theta. So like theta could be 90 or 91 or 95.67 or like 119.58 or whatever. But somewhere in between that values of 90 and 180. So if I think about my picture, between 90 and 180 is quadrant 2, right? Quadrant 2, the x is positive and the y is, or sorry, the x is negative and the y is positive. Okay with that? And I know the r is always positive. So sine theta is going to be y over r, which is positive over positive. So we'd say that's positive. Or you could write it this way. You know, cosine theta is x over r. Well, that's going to be negative over positive. Well, that should be negative, or you could write it that way. And you just continue for each of, for each of them or whatever. I don't remember if it's asking for just sine, cosine, and tangent, or if it wants all 6 of them. Jeremy, absolutely. So you said you also wanted to do a radians one. Do you have a preference?
50.
Okay. So I'm going to do the same thing. So 0, pi over 2, pi, 3 pi over 2, and then back to 2 pi. Again, 90 degrees is the same thing as pi over 2. And I'm just going to count around since this is not on the unit circle. So half, 1, 1.5, 2 pi, 2.5, 3 pi, 3.5, 4 pi, and then 4.5. So we're in quadrant 1. Right? 9 over 2 is 4.5. In quadrant 1, both the x and y's are positive, so everything is going to be positive. Yeah. So just, just figuring out what quadrant those angle measures lie in, and then just use your standard position angle definitions, or even unit circle definitions would be fine. And that's it. Is that okay? Absolutely. Okay. What do you guys think?
Just gotta memorize the cosine, theta, all those kind of things. They make the problems easier, like much easier.
Oh my goodness, you can't do it if you don't know them,
Yeah.
right?
I gotta memorize them. I don't know any.
Yeah. That stuff there.
Doesn't seem too bad. You just gotta.
But remember, if you know Sohcahtoa, opposite is y, adjacent is x, and hypotenuse is r.
That is true.
If you know Sohcahtoa and you remember that, you know everything to go from there to there. And going from here to here, just r is 1.
Yeah.
So basically, if you know Sohcahtoa, which probably we do, and we remember the reciprocals, and then we just remember those 3 things, and then r is 1. It appears to be a lot to memorize, but it's actually not. At least if you think about it that way, right? Jay. What, from the review? What page on the review? Third, page 3. Okay. I'm just asking that because it's easier to tell if not just sort of using yeah, for sure. So here I'm going to just be using the right triangle definition because clearly I'm working in a right triangle. So I need to figure out this side AB. I'm just going to call that X for now. So I'm going to use the Pythagorean theorem to do that. Remember, the hypotenuse is always the C. Um, 71, so 65. Okay. Next thing I'm going to do, I'm going to look at the theta that I'm given. So this side is the hypotenuse, this side is the adjacent, and this side is the opposite relative to that theta. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Cosecant is the reciprocal of sine, or you could think about it as hypotenuse over it, opposite. But I have to rationalize my denominator there. And 9 and 65 don't share any factors in common, so I don't have to worry about reducing. Secant theta is the reciprocal of cosine, or hypotenuse over adjacent. And cotangent theta is the reciprocal of tangent. And then again, we'll rationalize the denominators. And that's it. But that's definitely something you should be able to do for the test, right? When I say give you a right triangle and ask you to identify the 6 ratios, that's the kind of thing I'd be expecting to be able to do, which seems pretty doable, right? You just got to remember, you have to know which ones are the reciprocals and which one, know your Sohcahtoa, but there's not a lot of calculation, right? And in general, this chapter doesn't really take that much calculation. It's a lot of just understanding the relationship and making sure you know the formulas that you need. But none of these have required oodles and oodles of steps, right? Unlike our Algebra 2 class last year where we had some problems where it's just we had to grind through like 5, 6, 7 steps to get to an answer where there's a lot of algebra involved. Here, not a lot of algebra. Okay. Let's stop here. Can I have you guys clear your desks other than a calculator and something to write with? What? Yeah.
Is it doable without memorizing the things?
Ooh.
Okay. Thank God we learned how to do the unit circle.
Yeah. If you can do these units, it'll be okay. Yeah, let me pass these out and I can get you one. You don't really need it to do it, but if you want one, I can get you one. Might be one of these where maybe you just, you know, you look at it first and then you're like, oh, I'm good. But I have to.
Oh, no, it's good.
I don't know what you're going to use it for, but you
Mr. Klug, you said I could take it like tomorrow if you need time or something?
Yeah, that's fine.
Do you think I was lying when I hit my head?
No, I mean, I see your face.
Hit your head? Oh, shoot, let me see.
Hey, so do y'all though,
Dang, how'd you do that?
Skateboarding.
Dude, I opened my door yesterday and I busted my eye. It was late, I was studying, it was like 1 a.m. Mr. Cool. And I go to open my room door so I can go downstairs and get some food. And I opened it too fast and I stepped in and it like nicked my eye. So now it's swollen.
Leo, I just want to say for the record, you know you're supposed to land on your feet, not on your face, right, when you're skateboarding?
Well, that just turned into a face plant.
I see. I see.
I'm going way too fast.
There, Trace. You're welcome, Ronnie. Oh. Guys, I am so tired today. Did it feel like this weekend just like blooped and was gone?
Yeah.
Yeah, right?
When's our virtual day? Is that this week or next week? Is it a Friday? Please tell me it's Friday.
I think it's the middle of the week or
Are
something.
you serious? Why are we doing that?
Friday we have off.
Did we actually?
Is this Friday? It's virtual Wednesday and Thursday. Then off Friday.
No way.
This week?
That's next
No,
week.
next week.
Mr. Cool, are we having class?
So let's look here. We have the virtual day on the 6th and the virtual day on the 7th, and then no school at all on the 8th. So probably what I would do,
What day is it?
so Wednesday and Thursday are virtual days at home, and then the Friday is off. Probably what I would do is something similar to the when I was gone, where I'll just make the video for the lesson, and I wouldn't have like a specific class check-in and just be like, hey, you know, watch the video and work on this part and this stuff. Depending on where we're at, obviously, like if it's everything is done, you know, but
Those days when you have Zoom meetings or no?
I don't know, to be honest. They haven't been expressly clear what the expectation is. I would prefer not to have a Zoom meeting because you can listen to me teach a lesson just as easily from a video whenever as you could from sitting and watching the Zoom. And it gives you the ability to like pause and take a break and like.
Yeah, you might as well just come to school.
Yeah, 2 years ago, then when they tried that for math.
Oh, it was so hard to learn on Zoom.
Yeah.
We were doing geometry too.
Yeah.
Geometry is like not easy. Like you can't just look at it. Like algebra, you can follow the steps. Geometry, like
You have to think about it.
yeah.
Yep. But that likely that I mean it without any other